class, we were ending with a couple of these examples. I just want to start with a couple of these examples to make sure it's fresh in our mind, and then we're going to start the new stuff. So find the zeros of the function, then sketch a graph of the function. Finding the zeros, that just means to make f of x 0. And then we're going to solve it. And as of right now, we solve by factoring because that's all we know. So is there a greatest common factor? First step. Is there a greatest common factor? Okay. So I'm going to factor out the 3. Cam's not working? Okay. You could try sitting in a different seat. You want to come to one of these seats? Okay. So I pulled out the 3. Now we have a trinomial, which we are going to factor. It starts with an x to the 4th. So that means I'm going to have an x squared and an x squared. Using my signs, I'm going to have a minus and a minus. And that last number is a 1, which leaves me with only a 1 and a 1 as an option. X squared minus 1 can be factored further. X squared minus 1 is a difference of squares. X plus 1, x minus 1. And then we have a second x squared minus 1. So that's another x plus 1, x minus 1. And I'm just going to clean this up just a little bit. I'm going to have 3 x plus 1 squared, x minus 1 squared. And while I'm factoring and thinking about it, Sierra's working with me yesterday, and we found that I had a couple typos on that one factoring worksheet that you guys had due like 2 classes ago or something like that. And I saw some people didn't have the greatest of scores. But you guys didn't say anything. She's the only person that came and said something to me. So I went and fixed I had typos of my own. So I went and fixed my typos. If you haven't done it yet and you reload it, it should be fine. If you're like halfway through it and you reload it, it's not going to fix the typos until you actually just start all over again. It's on the factoring worksheet that was due like.
Was it the ones that you typed in the answers?
That you had to type in the answers, yes. Like there was a couple of places where I put a 2 instead of a 3 for some reason. Like I don't know, wasn't looking at the keyboard or something.
So you want us to retake it?
If you're happy with your score, you can be happy with your score. If I would suggest retaking it. You can really retake anything until I lock them. So, like if you're not happy with that score, you can take it as many times as you need to bring your grade up. Okay, I'm sorry, but that was something we discovered yesterday. So just FYI. Okay. All right, going back to this. So we are finding the zeros. So now I set each factor equal to 0. So I have x plus 1 equal to 0. And x minus 1 equal to 0. So I'm going to get -1 and I'm going to get +1. Now let's talk about the degree of this question. The degree of the original polynomial is 4. That tells me how many answers should I have? 4. Do I have 4 answers? Kind of. I have 2 answers, but both of these answers happen twice. I do have 4 answers. We just have repeated answers. So like this x equals -1 is repeated. And the x equals 1, that is also repeated. Not 2 times or times 2. I don't know which way is better. Times 2. There we go. you might also see, instead of repeated, you might see it being called multiplicity. You might see it being called multiplicity. Has a multiplicity of 2, if it happens 2 times. Okay, this is what we started talking about last time, is what will the graph look like? So this is a sketch. It's not going to be super accurate. I do know that at x equals -1 and at x equals +1, we've got x-intercepts because those are my zeros. Those are my solutions. So I know for sure that that is happening. And then we can use the degree, which is 4, which is even, and the leading coefficient, which is 3, which is positive. And that tells me my end behavior. So if it's even, what do the ends do? Good. I like the kinesthetic answers there. If it's even, the ends do this. If it's even and positive, they still go up like this. So I know that this is what my ends are going to do. And then the other thing that's important here is that we have multiplicity, and this is what was brand new last time. When we have multiplicity, this is the behavior that's going to happen at that x-intercept. So how many -1s do I have? 2. So at my x-intercept, it's going to look like a parabola. It's going to look like a square. And then we have 2 at this x-intercept, so we're going to have another squared-like figure. So I know that my ends are going to go this way. And I know I'm going to have a parabola at each of those. So somewhere in between, it's going to curve back around. This in-between part, that's stuff that we can get from our calculator if we needed to be accurate. But I think overall, what you're learning here are the things that you can pull out of the graph without having to use the technology, because then that shows your knowledge, your understanding of the graph. Okay, one more of these examples. We've got x cubed plus x squared minus 6. So we're going to find the zeros. That means we're going to make this side equal to 0. We are doing it by factoring. Is there a greatest common factor? Yes. X times x squared plus x minus 6. So we have to factor that. It's going to be a plus and a minus sign. 6 could be 1 and 6 or 2 and 3. What should I use for this one? 1 and 6 or 2 and 3? 2 and 3. Which one should be positive, 2 or 3? Ooh, I heard both answers. So this is going to end up positive. So I want the bigger one to be positive. Should be the 3. So that the bigger one is positive. When I multiply them back together, I get a positive 3x and a minus 2x, which gives me that positive 1x. Okay, so now I have x equals 0, x plus 3 equals 0, x minus 2 equals 0, x equals -3, x equals positive 2. So we have our zeros. If you're just asked to list the zeros, this is how we would list the zeros. If you're asked to list the zeros, it would be a list. Says we're also going to sketch a graph. So let's look at the end behavior. The degree. is 3, which is odd. The leading coefficient is 1, which is positive. So our end behavior looks like that. We've got an x-intercept at -3, at 0, and +2. And the ends look like this. Do we have any multiplicity? Did any of these x-intercepts repeat? No. It is a degree of 3. We should have 3 x-intercepts, and we have 3 x-intercepts. So there's no multiplicity. So these just pass through like they were lines. They're not, but they pass through kind of like they're lines. So just go straight through. And somehow we have to curve it around so they meet and pass through the other one. So there's going to be some maxes and some mins in there. Just have to make sure that at each point it just passes through. And we can check those on our graphing calculator, but we're just going to use our graphing calculator for the next few because we'll need it for the next few. So. Okay, so that was review. Sorry, FOD. That's a review from last time. Now this is where we're going to start using our calculator. Okay, I am trying to do like a half screen here because otherwise I can't see the equation. Brooke, I know you're doing it on paper. Oh, it's working now? Okay, good. Why is this not? Oh, that could move. I didn't know that could move. All right, now let me see if we can fix that color. All right, here we go. Perfect half screen. So let's type that equation in. X to the third. If you haven't started typing it, type it up. If you don't have your graphing calculator today, you're going to have to get on Desmos to use it. Desmos. Yes. Desmos. DESMOS. Type that equation in. All right. So if you have any, did you get on Desmos? If you have any calculator issues while we're doing this, you got to speak up. I want to know 10 minutes later that you couldn't do any of this. Like, I want to know right away so I can come fix it. Don't feel like you're interrupting, you're not. Okay? So I have it graphed. And then what we're going to do is we are going to pick 1, 0, 1 x-intercept. We're going to pick 1 from this graph. Okay, I like to work left to right. So left to right, where do you think the first one is? We're thinking -1, 0. Let me prove it to you that it is, okay? I want you guys to do second trace, and we're going to choose 0, because we're finding a 0, okay? So second trace 0. It says left bound. That means from this 0 that we think is at -1, pick any number to the left. What's to the left of -1? -2, sure. So type -2, then you hit enter. And it changed directions. Now it says right bound. So it wants a boundary that is to the right of this -1, which is anything 0. It could be 10 if you want, but what you're really trying to do is, since there's multiple places, we're trying to tell the calculator which one to look at. Sophie, what you need? And it said left boundary or left bound. So
I'm not where you are.
So the first one we typed in was -2. So do second trace. Start it again. Do second trace. And then pick 0. And then do -2, enter. And then what's it say at the bottom? Did you do -2 or -2? Okay, so now do 0, enter. Okay, you see how it says guess? So now it's saying, where did you think it was? And so we're going to say, well, I think it's at -1. By the way, your guess does not have to be super accurate. It's just the calculator is not a person we're communicating with. It's a machine. You have to tell it exactly what you're looking for, because otherwise it doesn't read your mind. It doesn't understand. So at the bottom it tells us -1, 0. So was Jaden correct? Is that one of the answers? Yes, it is. So we have used our calculator. Now what we're going to do is we're going to take it to the paper. And beep, beep. I gotta zoom out a little bit. We picked -1, 0, where x equals -1. That's what we did. It says use synthetic division to divide out that x-intercept. So we're going to take that -1, we'll put it in the little box. We're going to do synthetic division. And what's it mean if I have a remainder of 0? That means I'm good. That means that really was a solution. It says write the x-intercept as a factor. So my x-intercept was x equals -1. We're going to write that as a factor. We're going to do backwards what we did when we were finding the x-intercept from an equation. So what I'm going to do to this is I'm going to actually add 1 to both sides of this equation, and I'm going to get x plus 1 equals 0. So that's opposite of what we did when we were solving for x. We're kind of like unsolving for x. We're making it into the factor. So our factor, once it says equals 0, is x plus 1. So this is our factor, x plus 1. And we're going to repeat this process, but not for this example, but we will repeat this process until we're left with a quadratic equation. So at this point, when I had an original question that had a cubic in it, and we took out 1x power, this should be left as an x squared. So we are now left with a quadratic equation. Oopsies. Can't get this aiming. Okay, so what I'm left with is x squared minus 9x plus 20. It says factor, complete the square, or quadratic formula to find the remaining solutions and factors. So once you get to a quadratic, then you need to do factoring if it's factorable. You can use quadratic formula or complete the square if it's not factorable. This one is factorable. X plus, nope, not plus. X minus 4, x minus 5. And so I get x equals 4 and x equals 5 for my remaining solutions. Did it ask for solutions or zeros? What did it ask for at the top? Solutions, okay. So all of our solutions were, the first one was -1, and then we got 4, and then we got 5. I'm going to put those in order, least to greatest. Then we also are asked to write all the factors. So the factored form would be x plus 1, x minus 4, and x minus 5. And then that equals 0 because that's what the original equation at the top said. Oops. So we are combining, what's it called? Synthetic division technology and stuff that we've learned in here to completely factor equations and find all their x-intercepts. You ready to try another one? Let's try another one. Okay, I'm actually skipping the student practice because since we're also doing some of 4 or 6 today, we're going to get lots of practice in. So we're going to go to example 4. We're going to do the same thing. We need to start out by graphing it. So go to your calculator, type in the equation. Okay, so I got a few crazies. I got some up and down stuff. if you want, you're always welcome to change your window. You totally don't have to do what I'm about to do. But I feel like changing my window. I kind of want it to just kind of zoom in a little bit. So I'm going to go to my window and I'm going to make my X min and max just a little bit less. I'll go for -5 to 5. You totally don't have to do what I just did. It was so like squished together. I felt like I might be happier if it wasn't so squishy. Okay, so we're going to go from left to right, and we're going to find this first 0 using the calculator. It doesn't look like it's at an integer. So I'm going to do second calc and then 0. So left boundary, definitely -3. And then right boundary, I think -1. And then guess, I don't even have to guess that accurate. I know it's not at -2, but I can guess at -2 and it will be fine. So now it's telling me something that looks terrible. Yuck. I'm going to skip that one for right now. Okay? I see it. It's ugly. I don't want to deal with it. So I'm going to find a different one. I'm going to go to the next one over. Am I going too fast with the calculator? You guys speak up if oh, and if you're using the Desmos, you just like touch it. Just so nice. Did you wish these were touchscreen? That'd be great. But if you're using Desmos, you just have to touch where the two cross and it'll tell you. So I'm going to go to the next one over, and we're going to do it again. Second trace, 0. But this time my left boundary might be at like -1. My right boundary at 0. And then I'm going to guess at -0.5. Ooh, it was exactly at -0.5. I have a 0. Okay, first of all, we're going to write it as a fraction. Now I got to show you this. This is the fun part. Oops, meant to change color there. I'm going to write it as a factor. So we're going to write as a fraction, we're going to write as a factor. So x equals hello. Yep. Yep. I just need a refill. Lunesta. Yeah. Mm-hmm. 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 Yep. Yep. Nope. Nope. What's that? Oh, no. Not right. No, I need to do that. Okay. So what I was doing when I turned the video off, or maybe it was when I was talking still, we have to write this x equals -0.5 as a factor. So we need to make it say equals 0, but we can't have fractions in it. We can't have decimals in it. So what I did first was I got rid of the fraction by by multiplying by what is in the bottom of the fraction. I multiplied both sides by 2. Then what I did was I added the 1 so that it said 0 over here, making 2x plus 1 the factor. From here, 2x plus 1 is the factor. We can't use synthetic division, so we have to use long division. So reviewing long division, I'm going to take 2x and divide it into 10x to the 4th. So if we don't know that answer, we can go over here and say, what is 10x to the 4th divided by 2x? That leaves me with a 5 and an x to the 3rd. So after divide, what comes next? Multiply. So we're going to multiply, but you have to distribute it. So I'm going to get 10x to the 4th, and then 5x to the 3rd times 1 is 5x to the 3rd. And then we subtract. So I change the signs. I'm sorry, I draw the line and I change my signs so I can subtract. And that leaves me with, this cancels out, negative 16x to the 3rd. Now we divide again. 2x, nope, I forgot. And bring it on down and bring it on back. Now I divide again. I'm going to divide the negative 6x cubed by 2x. So if I divide negative 6 by 2, I get negative 3. And then x to the 2nd. And then we multiply. So I'm going to get negative 6x to the 3rd, and I'm going to get negative 6x squared. Subtract, draw the line, change the signs, and I get negative 36 x squared. Bring it on down and bring it on back. This time negative 36, negative 36x squared divided by 2x is going to give me negative 18x. Then I multiply and I get negative 36x to the 2nd, and then I multiply and I get negative 18x. Draw the line, change the signs. I add them together and I get, what am I getting? 25? That doesn't sound right to me. Did I make a mistake somewhere? Where did I do that? Oh, I totally did. Oh my gosh, thank you. That was fun. Let's go back and redo that. Was that Brene who said it? Thank you, girl. Even I can make a mistake, even as perfect as I am. That's a joke, guys. Okay. All right, so it should be negative 16. So going back to, now I feel like I need to hurry. Negative 16x cubed divided by 2x. It's going to be negative 8. X squared. Multiply, we get negative 16, x to the 3rd, and then negative 8 squared. $34? Yeah, 34. So negative 34x squared over 2x. That's going to divide and give me negative 17x. We multiply, we get negative 34x squared minus 17x. Draw the line, change the signs. and I get 24x. Bring it on down. And oh my gosh, we're almost done. Divide 24x by 2x. And I get 12. Multiply. Subtract, draw the line, change the signs, and I get a remainder of 0. That's good. Got a remainder of 0. It needed to be a remainder of 0. Okay. I currently have 5x cubed minus 8x squared minus 17x plus 12 as my quotient. Is it a quadratic? It is not a quadratic. If it is not a quadratic, we have to repeat the process we just did again. So we go back to our calculator. And we're going to find another 0. We already checked the first one. I did not like that one. We found the second one. Let's try the third one. So second trace value, not value, sorry, 0. Left bound, I'm picking 0. Right bound, I'm picking 1. Guess, I'm picking 0.5. And it's 0.6. Exactly 0.6. I really don't think I left myself enough space on this page. So I'm going to write that as a fraction. So x equals, what is 0.6 as a fraction? Tessa? 3/5, perfect. Okay, then we need to make it into a factor. So to make it into a factor, you're going to multiply both sides by that denominator. And I'm going to get 5x equals 3. Then I'm going to subtract the 3. And I'm going to get 5x minus 3 equals 0. So our factor is 5x minus 3. Okay? Can I use synthetic division? No. Have to use long division, and I've left myself so much space. You guys, we'll just like ignore this one. We'll just use this whole page. Probably should have zoomed in way far. Okay, so now I've got 5x minus 3 dividing into, and I'm going to go divide into. You ready? I'm not going to go all the way back to the original question. I'm going to divide into what the quotient was. So what I did was I divided out our first factor. Now we're going to divide out the second factor. So we're dividing numbers out a little bit at a time. So I'm going to use this 5x cubed minus 8x squared minus 17x plus 12. And we're going to do long division. So 5x cubed divided by 5x is x squared. Multiply. Draw the line, change the signs so that I can subtract. And I get negative 5x squared. Repeat the process. We're going to divide. Oop, nope. Bring it on down and bring it on back. Now we're going to divide negative 5x squared by 5x, which gives us negative x. We're going to multiply. and I get negative 5x squared plus 3x. I'm going to draw the line. I'm going to change the signs. Sorry, there's like this ugly thing right in the middle. I'm going to add those up, and we get negative 20x. Bring it on down. And I'm going to do divide, bless you, negative 20x divided by 5x, and I get negative 4. Going to multiply, get negative 20x plus 12. Those are exactly the same, so when I subtract them, I will have a remainder of 0. This chapter in this section that we've gotten to is probably one of the hardest ones you'll have the whole year. So this would be not the time to be in your own world, taking a nap, talking to your friends, texting. This is always like the hardest stuff. So at this point, we have 2 factors. We have our first factor. I'm just going back up through the work for a second. This is our first factor, 2x plus 1. We have our second factor, 5x minus 3. And now we have a quotient, x squared minus x minus 4. Oops. And we say, is that quadratic? Is it quadratic? Yes. So once you get to it being quadratic, now we can solve it the rest of the way by a different method. Will this factor? So the factors of 4 are 1 and 4 and 2 and 2. How can I make a 1 in the middle? Or a negative 1 in the middle. How can I make a negative 1 in the middle with 4 and 1 or 2 and 2? Anybody? Jackson? You can't. Okay, you can't factor it. Then what also can I do besides factoring? 2 other choices. Instead of factoring, what else can I do? If we have an x squared and an x, I can't just square root stuff. We could do complete the square, but if I do complete the square, the middle is odd. I have to do that b over 2. I'm going to have fractions. I don't want to do that. So what's our other option? Warm up those vocal cords. What's our other option? It's quadratic formula. Yeah. Is that what you're saying? Who's singing it? Brooke's singing it? All right, Brooke, sing it out. No, I'm just joking. All right, so just to remember, I'll put it over here. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. So that's quadratic formula. We're going to have to use quadratic. Well, we don't have to, but we're going to use quadratic formula. I don't want to use complete the square. So opposite b plus or minus square root b squared minus 4 times a times c all over 2 times a gives me 1 plus or minus square root 1 plus 17 over 2. The bottom is positive, Square root of 17 can't be broke down any further, and there's nothing that I can factor out to cancel with the 2. So that is in lowest form, I guess. So we have all of our answers. We have our first one was, actually it's our second one, was -1/2. Our third one was 3/5. And then we just found our first and our fourth. 1 minus square root 17 over 2 and 1 plus square root 17 over 2. So those would be our 4 answers. That one was like the longest possible kind you would ever have. We don't always have to do long division, because if the synthetic division ones, those go really fast. So long division that made that one hard. We don't always have to use the quadratic formula. Sometimes we do. But this kind of just put everything that makes these problems long in one question. If we have to factor this one, if we have to write it as factored form, as of now, what we know is we would have our 2x plus 1. We would have our, what was the second one? 5x minus 3. Oopsies. And then could we factor the last one? Could we factor this one? We couldn't factor that one, could we? So then the last one I would put as x squared minus x minus 4. Because we couldn't factor that last part. So that's how I would write that in like factored form. I would have the 2 factors we could get, and then the quadratic that we had to use quadratic formula for. I think we pretty much got to so I didn't get to this part, but this is the part that I was going to skip. Let's go to the 4-6 real fast. I'm just going to do a couple things from 4-6. 4-6 and 4-5 are like the same thing. We've already talked about that. So 4-6 and 4-5, they're basically the same thing. So we're going to do another example, exactly the same stuff. All right, so we've got, this is 4-6 notes. This is example 2. Type it into the calculator or into your computer. We're going to go through the graphing of this one. Why don't you start typing that in, and I'll make sure you can see the equation. It's just being slow. I know, complain about it all the time. Have it wrapped? Wrapped yet? Yes. Did you get yours wrapped yet? You don't think? Wrapped. That's the assignment. It's that's the assignment. Yeah, so get it graphed? Good. Graphed? No, we're still doing that. You type hers in for her. Thank you. Yes, dear. That's the assignment. There's a link right above it. Oh, Marty did the same thing. Notes. Got it? Got a draft? It's actually faster if you type it, as when you type it, use like the inherit to make it go up. You and like 2 other people. You almost got it? Did you get draft? Yeah. Okay. Couple of people are catching up. We've got the graph. And the first thing that we want to do is we want to find one of the x-intercepts. We want to find one of the zeros. So looking at this graph, I'm going to start to the left. And it looks like it touches it. It looks like it touches it at -1. So we're going to do second trace 0, left boundary. So since I think it hits at -1, I'm going to pick something to the left of that, -2. Right boundary, I'm going to pick 0. So I'm telling the calculator, look in between -2 to 0. Look in between there. I think it's at -1, but I want the calculator to confirm it. And it does say, yes, your 0 is at -1. So I have -1 for a 0. So we are going to take out that -1 using synthetic division because it's a nice not fraction answer. And when I set up my synthetic division, I have an x to the 5th, but I do not have an x to the 4th. So we have to have that 0 in, or we're going to have problems. We have an x to the 3rd. We've got -2x squared, -12x, and -8. So I'm going to do my synthetic division. And I use synthetic division, and I took out the -1, and I'm left with no remainder, so I've done it right. Let me write this as a factor. X equals -1, add the 1. I get x plus 1 equals 0. So x plus 1 is a factor. We started with the 5th power. We went down a power. Are we at quadratic yet? No. So now we go back to the calculator and we look for another 0. Can somebody help me find another 0 on the calculator? What do you think? 2? So second trace 0, left bound 1, right bound 3. Let's check at 2. It does say yes, 2 is a 0. So this is what we're going to do because x equals 2 is a 0. So make it into a factor really fast so don't forget. Okay. Because x equals 2 is a 0, what I do is I go and do synthetic division again, but I do not start over. I go off of my last numbers that I got from the first time I did synthetic division. Because we want to keep making this smaller. So we're going to go off of that one. So I'm going to do synthetic division, bring down the 1, multiply, add. Nope, I did something wrong. Can it? What? Oh, that's 8. Got it. I don't know why I couldn't see that. Okay, so I got 0 remainder, which is what I needed to have. All right, so I took out 2 powers. We started with a 5th power. If I took out 2 powers, am I at quadratic? No, I'm only down to 3. I was at the 5th power. I took out 2 powers. I'm now down to 3. So I can't use like quadratic formula or factoring at this point. There has got to be another 0 that I did not find yet. There's another 0 there. Where is it? Tessa?
-1.
-1. But didn't we already have -1?
But it like makes the problem.
Perfect. If it makes that parabola shape, that means there's a repeated solution. That means that -1 happens more than once. So while we're doing these this synthetic division, I'm going to have to take out another -1. So we're going to have a second x plus 1 factor. And it worked. I got x equals, remainder of 0. So that one did work. So we started with the 5th power. We took out 3 things using synthetic division. We now have 2 powers left. That is quadratic. X squared plus 4 equals 0 is what is left over. How do we solve x squared plus 4 equals 0? We can use the square root method. I'm going to move the 4 over. Oh no, what happens when I square root and put in a plus minus? What happens? Haven't heard the answer yet. What happens? I got an imaginary number. That's okay. We can still do that. Remember, the square root of -1 is I, and the square root of 4 would be 2. So we would get x equals plus or minus 2i. For the graph, how does that affect the graph at all? When we were looking at the graph, you guys only see 3 answers. We only saw -1, -1, and 2. Because the other 2 are imaginary, so it doesn't cross it more than those 3 answers. So for this one, if we needed to write it in, oh, there's steps for this. Oops. I was like trying to fit it in there. If we need to write this as like solutions, we would have -1, 2, and then we would have -2i, +2i. I like to just put the imaginary at the end because they don't really go in order. They're not really there, but they are solutions. So I just like to put those at the end. Now, if there's 5 solutions, why is there only 4 of them here? There's 5 solutions. Why do I only have 4 here? Because the -1 happened twice. So we do need to know that we should have 5 solutions, but this one happened 2 times. And that happened 2 times thing, that's not part of my answer. That's me just giving you guys notes. Okay, you don't have to write that. What about writing it factored form? The x plus 1, oops. The x plus 1 happened twice, so we write squared for that one. The x minus 2 just happened the one time. And then the last one, I couldn't factor. So x squared plus 4 was not factorable, at least not with real numbers. So that's as far as you could factor it if we're writing factored form. So I thought that I'd get through about here. Unfortunately, I wanted to have more practice with these. And I can keep recording the video and just make it longer and longer, but really it's more like you need to practice. So what I think I'm gonna do is let you practice some of this like on your assignment, we don't have to do the notes, on the assignment. And then next class, we will be still doing the same stuff. The only thing I didn't get to is you're gonna see some questions at the end of the worksheet that look like this, and it says write a polynomial function with least degree, whatever. That's the one part we haven't got to yet, so we'll do that on, when will I see you next? Monday? So we'll do that on Monday. That'll be pretty short. Everything else though, for the rest of the week, next week, is all just reviewing this stuff. That's all we're gonna do is review. We're not gonna take a test or quiz before break. I normally like to do that, but I don't wanna have to deal with all the quarantines and stuff like that. So we will next semester have a test or quiz on this stuff. But obviously when we come back, we'll review it before we do that. But I wanna kind of get it down before we go on a break so we don't have to do as much review when we get back. Okay? So work on either the rest of the book work from the one that was half due today, but I didn't post any answers because I'll post it all together. So work on that. Or if you're past that, start on the worksheet. Work on this stuff now so I can help you with it. Work on it now so I can help you with it.